All right. So, good morning, Mike. Thank you so much for joining me. I really appreciate it.
Thank you. Thanks for having us.
Yeah. So, today we have Mike from Sequoia Electric, and he's going to talk about luminaire lighting level controls. And this is going to be a great bonus tech talk that'll supplement a lot of the things that we're talking about in class. And so, I'm just really excited to have you here today. And with that, I'll pass it to you to do a quick intro, and then we'll have your presentation, and I'll ask you a couple questions at the end.
Thank you.
Awesome.
Thanks,
Thanks.
Julia. Um, Hi. Sequoia usually has a role over at your school, and I'm excited to be asked by Julia and by Sequoia Management to help explain LLLC and what it is and what it means and where it applies. Before we get into that, just a little bit about my position with Sequoia. My job title is lighting controls and control specialist, and that's where things are moving. That's where we're going with LLLC. Is everything is basically in the fixtures. So previously, there would be two separate positions: lighting and lighting controls. My experience and my background has kind of melded the two, and I'm able to do both for Sequoia. So, what that job actually entails is working through the different DD phases and CD phases with our engineers and our GCs to make sure Sequoia has the best system possible as it pertains to design build. Try to keep pricing under control, because for larger projects, million square foot and up, which we do many, the lighting packages are a big cost factor. And by the time the fixtures are purchased, to when time to install these fixtures in the field, it could be years. So the difference in the technology changes rapidly, like we know today. So there are a lot of changes and a lot of developments that can happen over a year, 2 years for when these fixtures get installed. So my job is looking after the lighting package and the controls. So I help design most of the controls for our projects. If it comes specified, usually on a specification we'll have 3 or 4 different controls manufacturers that are allowed to bid on the project. I vet each one to make sure that they're code compliant. Also looking at all the device types and everything like that to know how many components, because each component takes a different amount of time to install. So we have to allocate price to that as well. So these are the things that Sequoia does a little bit differently than a lot of other ECs. We look at all aspects. Also, we have the potential with my position also to value engineer things. They say VE. We like to say design to value, and that's a new terminology that we use here at Sequoia. And it's just bringing the best value to our clients. So as it pertains to lighting and lighting controls, we can design everything in-house and provide an alternative package to a lot of projects. It's best to help our clients get through the transition from DD to CD, then all the way to installing, because things change a lot. Budgets change, labor rates change. There's a lot of fluctuations in our market, and over the progress of a project, to have a partner like Sequoia definitely helps. So as we get into luminary light level control, you'll see where this technology fits and where it doesn't actually fit. There's a lot of areas that luminary light level control won't help. and there's a lot of areas that it does. It was mainly first designed for and based around Title 24. So I guess let's start diving into it and see where we go with luminary light level control. I figured the best way to introduce, because everybody has different experiences, different market experiences, different backgrounds. Some are electricians, some are architects, some are ECs, some are GCs in this course. So what we're going to talk about as it pertains to LLLC is how we got there. How did we get to where we're at right now with luminary light level control? We'll cover some lighting concepts, control concepts, and then we'll dive into actually what is luminary light level control. And then we'll take a look a little bit at lighting control futures, where we see the market going, possibly, where we're at 5 years, 10 years, 15, 20 years down the road. How the life of these systems will progress. And then we'll do some closing and some Q&A. So enjoy. Thank you very much for having me. How do we get here? The LED lighting industry will be worth an estimated $127 billion by 2027, expanding at a CAGR of 13.4 over the forecast period. That's where we are, but how did we get here? The tungsten filament was the basis of design all the way until the 1950s, when commercial world was turned upside down by fluorescent, mercury, and sulfur bulbs. In short, color rendering became an issue. That's when color scientists took an interest in assessing the ability of artificial lights to accurately reproduce colors. The spectral and electrical distribution of fluorescence, for one, at the time created spikes in green that caused all types of issues in color rendering, peripheral distortions, and at the time, unbeknownst to most, extremely high flicker rates. As more commercial office schools and government buildings adopted the fluorescent tube, a growing need to address dimming switching arose. Not only did buildings see drastic decline in electricity over time, they required less power to cool that infrastructure. They saw the potentials in thermal savings. If you think about these buildings, I mean, they were mostly tungsten, some halogen at the time, mercury. I mean, they created a lot of heat. So that created a lot of thermal pluses in buildings and excess, which needed to be cooled. The overall building temperature came down after fluorescents were installed. I mean, at the time, there were mercury ballasts, and they created a little bit of heat, but not to the extent of the halogens and mercuries. Less air conditioning was needed to cool buildings of all different types. The fluorescent bulb was a technological marvel by the middle of the last century. This created a vast opportunities to manufacture all types of lighting fixtures. In fact, some might say it changed architecture altogether. By adding greater amounts of electrical light, engineers and architects saw potential to modernize the building envelope. And that's one thing I really think affected architecture, was this change from past technology over to fluorescence. And they could do so many different things. They could bring in light to the center of buildings where they were reliant really on windows previously. So a lot of things changed. Architecture had changed due to the lighting advancements. Being able to light the inside of a building with a reduction in power usage over the filament bulb had caused some funny stuff to happen. As you can see, some of the pictures here of buildings, architecture. We got a local one down there. A lot of concrete, smaller windows. That's what we saw happening back in the 60s and 70s. Now those fluorescent tubes over everyone's head were bright. I mean, really bright, and they had only, to date, toggle switches on the wall. Turn the lights off, it's too dark. Turn the lights on, it's way too bright. These fluorescent lights needed ballast to ignite the gas inside the tubes. The ballasts at the time were big magnetic types, only allowing switching. Some manufacturers of these fixtures started to include multiple ballasts that would allow switching, half tubes on, half tubes off. The fluorescent switching revolution had begun. And by that, I mean, once that happened, every building had twice as many switches on the wall as they did before. So you would come into a room and you turn on both switches. If it was too bright, you'd turn off the other switch. It wasn't until the introduction of electronic ballasts in the early 1990s, it's hard to believe, that dimming actually progressed with fluorescence and became commonplace. At the time, ELV, electronic low voltage dimming, was at its infancy. There had been some progresses along the way over the last 30 years with ELV dimming, but until that introduction in the late 80s, early 90s of electronic fluorescent dimming ballast, phase dimming was the only way. And as the ELV progressed over the next 5-10 years, sine wave technology that was just coming of age to compensate for triac dimming was put in its place, and magnetic ballasts were basically sought out by the Department of Energy and replaced with the electronic ballasts. There were, at the time, some loud triac dimmers installed in buildings over the period of 1980 and 1995. Triac dimmers, what they do is they create a resistance, and that equals noise in some cases. So the technology got better with the introduction of ELV, which let us get into ELV dimming, which we'll get into a little bit of what the difference is between triac, ELV, and we'll touch on a little bit of 0 to 10 stuff. And all of this is to get a handhold on what we're seeing in technology today with our luminary light level control, because it's done many different ways. What's allowed these advancements? We touched on a little bit in the previous sentences and the previous slides. The commercial and residential lighting worlds in the mid-90s saw a couple types of dimming start to evolve around fluorescence. Electronic ballast progression in major manufacturing had pushed resistor and capacitor development costs lower, allowing for more intrinsic resistor capacitor developments. And that gave rise to the compact fluorescent bulb, which probably you can still go by today. Having those capacitors smaller and resistors smaller allowed for that very design that you see on your screen right now. That little ballast is right above the A19 socket, and we still can buy those today. Better technology gave rise to advanced dimming capabilities. Reverse phase dimming, ELV dimming would become the benchmark for a couple of years until North America adopted the 0 to 10 protocol in commercial applications for the most part. I say protocol, but it's not really a protocol. It's just it's an analog signal. And we'll get into some of the protocols, what the difference is between protocols and dimming technology. There's really only a couple types of dimming technology, and we see triac, ELV, and 0 to 10. Touch on a little bit of 0 to 10. It was commonly used in the entertainment world and had even a standard drafted Back in 1997, it was called ESTA E13, and it was commercial adoption of the simple analog signal would help progress the 0 to 10 in commercial buildings after that. And for instance, 0 to 10 is an older technology. It's what is really used in most commercial buildings these days when it comes to lighting dimming. Unfortunately, the U.S. is really the only country that still utilizes 0 to 10. I'm from Canada originally, and majority, probably about 80% of dimming technology up there is dolly, which utilizes pulse width modulation. Europe, it's all dolly. It's just the U.S. that uses 0 to 10. Now, that's not to say anything bad about 0 to 10 or anything bad about the other technologies. It's just a way, and the way that the commercial market here, the manufacturers have found to keep the price low on their drivers is to utilize 0 to 10. Now, that progression in the drivers today with the technology, you can find most manufacturers will supply a universal driver with their lighting fixtures, which will do 0 to 10. It'll do pulse width modulation with the 0 to 10. It'll do ELV, and some might even do some phase dimming magnetic. So a lot more manufacturers, progressive ones, are providing these drivers that are universal. How well they work and how well they dim is another story altogether, and that's an issue that we see as it comes to starting up these systems, how they dim, the different dimming types. And we'll touch on that a little bit, I think. So the industry today, it's hard to find tungsten filament bulbs or even halogen bulbs of any type or quantity. The DOE, Department of Energy, has put restrictions on the sale of these bulbs, and thus has a detailed phase-out process to advocate the adoption of LEDs. In Washington State, PSE currently offers incentives for updating or designing around the LLLC designation. With a $75 fixture grant for each luminary, with integrated light level controls, it's hard to ignore the subsidies handed out by this advanced technology. If we look at what each one of these lighting fixtures typically costs, the savings are more than worthwhile. A typical troffer will cost between $150 and $400, depending on the quality of LEDs, light distribution, output, luminary, lumens per watt. So let's take an average of, say, $275 a fixture. Add in integrated controls, LLLC, for $50 a fixture, depending on the type of fixture. Now it's a $325 fixture. That a developer or contractor can apply that $75 rebate at the end of the project, and it equals a $250 troffer, said and done. The savings of $25 a fixture that has controls built in, that's the 10,000 foot view. Right here in Washington State right now, it's $75 rebate on each fixture. That's huge if you're talking about energy rebates. And we'll touch on a little bit of the commissioning later on too. We'll talk about the differences between pack control or panel control and what LLC provides. We'll look at the types of communication and protocols they operate with. So like I said previously, there are many different concepts that go into lighting control, and there's many different topologies. There's only a couple different dimming curves, but we're going to touch on all that so we get to that point where we can talk relatively about where LLC is today. Lighting control concepts today. Each one of these requires different control strategies. For example, Washington State Code does not require plug control, but Seattle Energy Code does. So depending on the location, different control strategies, designs are needed to fulfill code. Depending on pricing and installation type, lighting control panel might suffice as astronomical plug control, or maybe a distributed relay pack connected wirelessly to a luminary. So when the area is unoccupied, the sensor sends a signal to the relay pack, shutting off the receptacle. Same outcome, different strategies. On here, on the screen, you see why we actually need lighting control in fixtures. You can go over mandatory energy code, city code, design requests, energy reduction codes, comfort, automation, architainment, IoT, marketing, egress, emergency egress, and FAA warnings, lights on the top of high rises. On the screen here, we go over the dimming protocols. We're talking about phase dimming, which is forward reverse phase. 0 to 10, which is an analog signal, which sends 1 to 10 volts low voltage into the driver. And then pulse width modulation. Most of the pulse width modulation, recent developments, and that's used in conjunction with 0 to 10, it allows 0 to 10 to dim digitally. So there's not too many drivers out in the market right now that are still solely analog 0 to 10. You can still buy fluorescent troffers. In fact, sometimes they're a lot cheaper to use in elevator shafts. So they'll have fluorescent troffers in elevator shafts or someplace, that if it adds up to a couple hundred fixtures on a project, elevator shaft plus little bike rooms and stuff like that, they might actually specify fluorescent fixtures. So you can still get them. But for the most part, most drivers these days mix 0 to 10 and pulse width modulation. So you allow analog to mix with digital, and it's much better control. You can see there's two different dimming curves there at the bottom right hand of your screen. There's linear and then there's logarithmic. And this is one thing that lighting designers really don't consider when they start mixing different driver types in the field. The pulse width modulation was first introduced to allow your computer monitor to actually dim with different hertz frequencies in the early 90s, and it was quickly adopted when LEDs hit the market. This pulse width modulation strobes the driver in either a linear or logarithmic form. It's up to the lighting designer of that project to ensure similar dimming behavior between fixture types. We'll touch on some Dolly, some DMX, PoE, Ethernet-based systems that use communication protocols to tell pulse width modulation drivers to dim the actual LED fixtures. This allows for seamless digital balance and control. One of the things that lighting designers should strive towards is keeping unison linear dimming or unison logarithmic dimming for areas, not for an entire project, but for zones. And what I see coming in from the lighting designers all over the place is a mix of stuff, because they mix fixtures and they're looking at aesthetics over electrics. So electrical characteristics. Now we just touched a little bit on Dolly and and DMX and PoE. So there's dimming, which is phase, 0 to 10, and pulse width modulation. Those are the only types of dimming. As it comes to protocols, there are hundreds of different protocols. But in our field, in the lighting controls markets, this is what we and I deal with mostly. You have proprietary from manufacturers, Lutron, Crestron, they all do proprietary dimming control. So they all have their own little names for them. Dolly is, like I had mentioned before, up in Canada and Europe and the rest of the world. Dims with pulse width modulation. DMX, also a different protocol, used a lot, more so commonly these days. DMX was introduced primarily for show control in the film and television world, but we've brought it over. It's being used all the time in buildings. Most of the systems that I see and I design for the exterior of buildings are DMX. You have another protocol there is Ethernet-based TCP/IP. Then you have wireless, Bluetooth, Zigbee, and then there's other proprietary ones. You have PLC, BACnet, LawnWorks, and Modbus. Now, BACnet they have their own certifications and stuff like that. A lot of bigger facilities, industrial facilities, and like that will use BACnet, LawnWorks, or Modbus to interface all the different HVAC building types and communication protocols, so they can actually link them all with one protocol and see what's happening. Wireless protocols used for LLLC are linked to drivers inside fixtures and are commonly dimmed with pulse width modulation currently here over 0 to 10. It's notable that that's the way LLLC has evolved here with 0 to 10 and pulse width modulation. If you can't really, DMX you could LLLC, and Dolly you could LLC, but any of the other ones, it's like PoE is evolving to the point where we could get luminary light level control, because PoE systems, they're single addressable on each fixture. So technically you have LLC, but you don't have the sensors built into every single fixture, or even a lot of the fixtures. In a lot of the PoE systems, the sensors are still separate. We'll take a closer look at wireless, because really wireless is where LLLC gets its rebates from. There's less install time with wireless controls. So you're not only getting that $75 rebate here in Washington back, but it takes less to actually install these systems as well. So that's beneficial also to the contractor. A closer look at wireless shows that we have three main frequencies that we work off here. There's 434, there's 900 megahertz, and there's 2.4 gigahertz. And I've added a frequency list there at the top left to kind of tell you where we are in the wavelengths. 434 is common. It's been used forever. It's very low power, and it's like a garage door opener. Lutron utilizes 434 for their wireless, and it's low power, and the wave doesn't really go that far, which means communication can sometimes be an issue. But if you add in more hubs that bounce the signal back and make them communication better, then it works. 900 megahertz, the wavelength is a little bit longer. It penetrates a little bit better. Typical 900 megahertz system, we don't see a lot of hubs, but it is more expensive. So that's the difference. It's line of sight, you're looking at 1,500 feet in best case scenarios. But you put some thick concrete walls in place or a lot of drywall with insulation, stuff like that, and you get reductions. So, it's a bit different. Acuity, I think, is probably one of the only manufacturers out there that do their LLLC with 900 megahertz. And it hasn't been until just recently that they've developed a mesh with their 900 megahertz. Before it was just single band 900 megahertz sending out to each device. Now they've meshed it all together. So each device kind of pings back. That's what we typically see in a 2.4 gigahertz system. Zigbee, for one, is a common protocol, wireless protocol in the wireless frequencies. It's 2.4 gigahertz, and it provides a good coverage because everything's in the Zigbee protocol is a mesh. So every device pings each other. Their RXs, their TXs, so they're transmitters and receivers. It doesn't typically go as far as 900 megahertz. So that's why the mesh network works better. Now, like I just said, the 900 megahertz, they brought in a mesh with that now. So we're waiting to see what tests come back and white papers come back on that. So that's the three wireless frequencies that we're seeing in the market currently: the 434, the 900 megahertz, and the 2.4 gigahertz. As we progress past 2.4 gigahertz, I'm excited to see what the next step is. And we've all heard of 5G and everything like that. But 5G is going to require many more TXs and RX because the signal is even weaker, and but it can supply a lot more data, and I think that's probably what we'll hit on later in this when we talk about the future of lighting control. Is the data transactions that are going to go through these systems, especially with COVID coming in and workplaces being more concerned and employers being more concerned with health. And when you walk into Sequoia here, you have to fill out we have our own app that asks you, have you been in contact with and then you have to take your temperature and all this paperwork to fill out. So it'd be nice to know if somebody sitting at their desk has a raised temperature. So all that data and everything like that has to get back to a head end eventually so it can be processed and analyzed. 2.4, like Bluetooth, Zigbee, it's a good frequency for sending and receiving information, but a large amount of data, not so much. It's not like your cell phone, which can stream a lot of content and everything like that. It's a different low power 2.4. So that's the differences in the wireless frequencies that we're seeing in controls in LLLC. And we're going to touch on what exactly luminary light level control is and some of the different topologies that we're seeing in the market. So this is one topology. I can't get into all the different types. There's probably 5 or 6 that are prominent in our market here in Washington. Manufacturers that will supply LLC, but I've used this one as a good indicator because it's probably the simplest one. It has the fewest devices, but it still shows you what the topology of an LLC system is. Component-wise, you have a light fixture. That fixture has a driver inside and typically takes 120 to 277 volts AC. You have integrated sensor, the one there center left. It's usually called a node. That can most likely be found at one end of the fixture or in the center, depending on fixture design aesthetics and what people want to see. These embedded components have digital dimming, occupancy sensing, detection utilizing PIR, microphonics, daylight harvesting, usually with a built-in photocell. So that one center left there, that is a dual tech. So there's microphonics, there's photocell, there's PIR, everything in one in that little tiny sensor, and it would go into mostly every fixture. But not every fixture requires occupancy or daylight harvesting. Depending on the layout of fixture types, some might only have a network interface node, another embedded device with a motion sensing or PC. So it would be that radio component, but without the optics on it. In an LLLC system, everything is addressable. Typically in an addressable system, you can change the addresses and all that kind of stuff. With these, the addresses are pretty much set out of the factory. You can see what that address is as you get into the commissioning, but you can't typically change what that address is because it's set by the manufacturer and it has to communicate back to a head end. Whereas like a DMX system or a Dolly system, I can change addresses on whim. In mesh networks, this helps with boosting signal strength, as I described with the 2.4 previously. So each one of these little radio components is a TX RX. So being that you have tons of these in each fixture, signal is boosted and it communicates a lot better. Let's take a deeper dive into where best to use this technology. So let's look at a classroom with large windows along the right-hand side. There's a room entry switch and a whiteboard at the front of the class with a touch screen. You can see the little TS there at the top right-hand side. Using distributed relay controls like, say, Nlight, a Wattstopper, a Hubble on X, you can figure out, can you tell me how many zones or relays will be required to meet code? It's a tricky thing with those windows along the right-hand side and multiple zones. And, the whiteboard's going to need its own zone. So the front one's dimmed down. When they hit that touch screen and the teacher, he or she wants to present something. So you don't want those lights above the screen to be on. So there's multiple zones, multiple scene controls here that are possible. And then we also have to worry about emergency as well, because that's going to be another zone also. Using a wired distributed lighting control systems, you would need 5 regular 0 to 10 dimming relays and one emergency one. So if we take a look at this, we'll require multiple zones of control. Dimmings required everywhere. Daylight harvesting is required. Occupancy, vacancy is required. Lighting scene control with your touch screen, that is optional. And shade control, which is more commonplace these days, is thrown in there. Emergency egress and plug control. Plug control isn't Washington State, but it is Seattle. And more or less, we see it getting put into all larger facilities. So we're looking at I think I have 5 regular 0 to 10 dimming relays and 1 emergency 0 to 10 dimming relay, plus occupancy sensors, ceiling sensors, dimming sensors, all these kind of things. So At the top left here, you'll see a network system that gets into those packs. There's 4 packs, regular 0 to 10. Then there's the dimming 0 to 10 emergency. Then you have a PC, a photocell dimming pack, and then you have an occupancy sensor. So a lot of devices, a lot of installation costs. Cost estimate rough equals 1,100 plus wire plus install time for the packs and sensors. You're looking at a lot of money to install all this stuff. What I have as a guesstimation is roughly, I think, 2,075 for that network system to be installed. The bottom left here shows the wireless LLC system that is a lot different. The cost estimate is 450 nodes and adders to fixtures plus $100 wireless switch, 400 plus for a touchscreen equals 950. We have add in the entry switch, touchscreen, dual zone daylight sensor, photocell, ceiling occupancy sensor, all that kind of stuff that goes with the network system, the distributed network system. It's a lot of stuff to install, a lot of components. You need Cat5 to I've got it shown there in blue, Cat5 for everything. With the wireless LLC system, there is no wires. All you need is circuitry to the lights. So 120, 277 to each light fixture. Then you need your emergency circuit, of course. And you can see that the cost estimate is drastically different. Now, add in that there's even less components to install. The electrician doesn't need to put in a photocell. He doesn't need to put in the aux sensor. The wall station, the switch is battery in most cases, unless you want it wired. So it's just stick up on the wall. But in this slideshow, what I've added is all the rebate information, all that kind of stuff. If you want to dive into it, is available on that link at the bottom there, the PSC link, and it goes into details of power usage and wattage and everything per square foot and what you're allowed, what you're not allowed, and all the details of what an LLLC system actually entails. So you get the rebate back if you're a contractor. All I can say is the majority of systems that we're seeing out there are still wired network systems, Cat5 systems. Whereas an LLC system is commonly wireless. I would love to do more of them. They're not commonly specified in our market other than some schools are utilizing them, mainly because of the daylight zones, the daylight harvesting, the multiple zones. I know multiple colleges are taking advantage of this because more colleges, universities are using flex spaces. So flex spaces are perfect for LLC because if you have furniture that's getting moved around and you need different scene control and different zones from week to week or month to month, it's easy to switch. Now, I don't really get into a lot of the commissioning in this, but for the most part, all these manufacturers, all their wireless systems it doesn't matter if it's a multitude of manufacturers that I mentioned, all of them have apps that are supposed to easily commission these light fixtures. Now, each one of them, because they're addressable in the LLC, will require commissioning to some extent. So we can go back to, if you look at the bottom left here, and we have our LLC system installed in the school, we can talk a little bit about which ones would require the full sensor range and which ones would just be repeaters. So most likely, I would put in that room like that size, probably 4 of the lights would have the motion sensors, the PIR and the microphonics. Maybe 5, maybe that center one would get one as well. And then typically the rest of them would just get just silent nodes, which allow for luminary light level control, communication between all the rest of the lights, all the rest of the system, but they don't have sensors in them. So they're not individually fluctuating daylight controls and light harvesting. They would get their information from the light fixture next to them or the light fixture next to them. This reduces cost. It also reduces lights around the same line being at different intensities. One of the issues with luminary light level control is, let's say if I'm in a hospital and I'm pushing a cart, I got a stainless steel cart and all my lights above me are LLLC and they all have sensors in them. They all have PCs, daylight harvesting. And I push that cart and it stops and it's getting reflection from the light. That PC will sense, because it's a closed loop, it's going to be looking straight down. It's going to see that intensity, that reflection back, and it's going to dim that light down. So you'd have one light and a row of lights just because there's a cart right below it that's going to be at a different intensity. So that's kind of like one of the issues that we see with every single fixture having photocells in them and sensors. So the systems need to be designed correctly for the application. And that's one of the things. You can't just blatantly blanket everything with sensors and daylight harvesting. It actually requires some thought. Now, from a lot of the manufacturers, you'll hear that, you can just throw in all the sensors and that's everywhere. And no, you don't have to worry about stuff. But ones I've done and designed and installed and commissioned, you have to think about those things because you have to think about who's going to be using this system, what things might be affecting the daylight harvesting. And we've gotten to the point now where these sensors can be adjusted. So when a cloud passes by outside, it has a lag time of, say, 30 seconds. So that fixture does not dim down. These are all things that need to be programmed into these fixtures. The sensitivity of the daylight coming in, the lux levels, everything needs to be calibrated and set. So to commission these systems, the LLCs do require a lot of work and a lot of attention. They don't necessarily require a lot of different zoning and circuitry and stuff like that. That one room would get 2 circuits. Whereas that top left one, still 2 circuits, but you need a lot more wiring to the packs. And then from the packs, you need the Cat5 to connect all of them. So big difference between wired and wireless systems. One of the major concerns with wireless systems is security. And I'm not going to get far into where the issues are with security and what the positives are about the security that we're seeing these days. There are pluses and there are minuses. But it's something that really needs to be considered as you put these wireless systems into facilities, and what type of facility and what type of security you need to go with it. I'm going to touch a little bit on the types of security that we're seeing out there for wireless protocols. With Bluetooth systems, with Zigbee systems, security is definitely at the top paramount of what needs to be looked at. a couple of years ago, I think it was probably about 7 or 8 years ago, a major retail chain was hacked through their wireless thermostats. They accessed all kinds of information, personal credit card information. Since then, there's been a lot of changes and new measures put in place to avoid the same thing from happening. So even though, the lighting control was wireless and it had its security protocols and everything like that, the one thing that really wasn't thought of was this wireless thermostat that they put in this major retail chain. And yeah, hackers got in, they hacked the bridge that links the thermostat to the head end, which is probably a backnet system of some type, and got in and accessed all types of information about clients. So there's been a lot of new protocols, processes put in place, blockchain and stuff like that since that's happened. Wireless cybersecurity is a big part of LLC systems. It's worth looking in depth at another time, and I could talk 45 minutes on the different types of wireless security, because just like the different types of wireless systems that manufacturers are creating for LLC, there's just as many different types of security systems. Each one has a different one. Each one brags that they have the best, but we can break them down and look at them and see what they actually are. As you see there, California introduced cybersecurity compliance. UL has developed one, which I think is a great idea. But then, that's standard. And once you get a standard of security, it has to evolve with the time. If it doesn't, then you're basically writing an open book for hackers and thieves that want to get in and get that information. You're making it public. You're saying what types you have. So I put a link there at the bottom there. The DLC website is a great source of information. The spreadsheet is amazing. What they actually tell you for each type of system. Is it secure? What paperwork it has to back up its certifications. So just as much as the frequencies and topologies of LLCs, security is just as paramount. I don't see a lot of wireless systems getting put into schools, mainly because of that reason. People are afraid, specifiers are afraid of wireless security protocols. Usually a school, once it's networked and everything, has its own server base. So it's, you could have it linked to the outside, or you could have it standalone. Usually the lighting systems are on that standalone system where it's maintained. Now, if it is linked, then there's other security issues that we have to comply with and discuss. But as I get into LLC and designing these systems, one of the first things I do personally, one of the first things that we do at Sequoia, because we have a large network services division, is I discuss how many IP addresses I'm going to need, what type of security we're going to be providing with this system. And being that we have our own IT group, it's easy to communicate, but a lot of ECs out there that are installing these systems don't understand the amount of attention to detail it requires to get one of these systems up and running. So we can look towards the future of lighting control and where we go from here. If we take a look at a building today, a lot of the buildings that we work with today, with the BMS system and everything like that, they look like this. It's generic building flow. You have your building management system, you have your database, you have your automation systems, temperature, occupancy, electricity, temperature, controls, then your outside weather platform, which will determine how your thermal is controlled on the inside of your building. This is a network building flow chart, and this is how we look at systems. This could be a backnet system with each one of your building automation system, your temperature, occupancy, temperature, building information, and electricity being a different protocol. Could be a mix of TCP, could be a mix of Modbus, and all different types. But the unification, we generally find this in a couple different divisions of the specification, which is division 25 and 26. So data collection is the predominant force moving the benchmark. All the BMS systems are derived to produce data that will better allocate resources for the facility. Whether it be BACnet, LawnWorks, or Modbus, data is the future. With the emergence of 5G, faster data speeds will be achieved. Most devices today are found in current BMS systems run off older technology. So this generic data flow, some devices will actually have wireless devices. Some older devices will actually have newer wireless devices put on them so they can actually communicate with the current topologies. I think personally what we're going to see, and I would love to see, is a joining of Division 25 and 26. Division 25 is the technology spec, and Division 26 is the electrical spec. It would be nice if at some point we start talking, because we play a lot of catch up with the technology spec. And, the manufacturers are looking at where the technology is going. They're working on stuff 5 years ahead of what I'm going to see currently. Whether a lot of those technologies come to fruition or not, I talk with the manufacturers a lot about what's coming down the pipeline and what they see. But with the introduction of 5G, I really think we're going to have faster speeds. We're going to have the future of lighting is we're working on designs now. Lighting is everywhere. It's in everything. It's in all the furniture. It's in all the walls. It's all linear fixtures everywhere. There's streaming contents and stuff like that. That's what our SNS deals with, our Sequoia Network Services, streaming content on everything, not only on TVs, but now entire walls are illuminated and there's content that's going to be needed on that for marketing and everything like that. All of that is going to be, I'm hoping, in a technology and electrical melding, so that we keep on the same path together. Marketing and is a big technology curve attribute. So where we see lighting being introduced to provide marketing, whether it be streaming or supplemental content, it's definitely one area where things are progressing fast. Another area I really think is on the rise in some of the buildings that we're doing now. I mean, they want to count how many people there are in a room. Now, there's two reasons for that. Really, two reasons. One is to know, the temperature of the room. We can figure out by body temperature how much HVAC is needed for that room. And for two, to not have too many people in an area because of COVID and other things that might be coming down the pipe. more manufacturers and even employers are starting to think about this stuff. So, if I have a system that will allow me to look at a temperature of a room, why can't I look at a person? I won't know their face or anything like that or who they are, but their actual temperature. There are systems that are put into restaurants and fast food chains over in Europe. I've worked with a couple of them, the technology that they're using to count how long a person is in line, to look at its facial recognition, its facial features. Is it happy, sad? Does it keep on reaching for something that it shouldn't be? These are systems that are coming down the pipe, and it's all about data flow and where that information gets sent. So now that we've talked about where our systems have come from, the technologies that have got us to where LLC is today, I hope that there are some questions that we could discuss and that hopefully I can answer and help shed some light on LLC. Thank you.
Awesome. Thank you, Mike. That was great. I learned so much. And I was jotting down questions along the way, and then you would answer them right after I thought of that question. Like, for sure, I think that the cybersecurity issue will be a big thing to consider as this moves forward and as we just start to get more and more data in general, right?
I mean, each one of these manufacturers has an IT release, security protocol release that they can provide. And that's, I mean, for government facilities or any schools or anything like that, they should be able to provide that information. And that discloses all their technology so that the facility knows that they're getting what they're paying for.
Yeah, that makes a lot of sense. I was just thinking about if we did have class in person this year, I can see some really smart students figuring out how to hack in and mess with
Especially
things.
when you got Bluetooth beacons all over the place and open wireless, access points. Yeah, it's a little bit scary.
Yeah,
a lot of these systems don't deactivate their Bluetooth. Their wireless on the 2.4 Zigbee is constantly. I could pull it up on my phone. I don't have the password for it, but it's not really that hard to figure out. And once you get into that, what other things can you get into? So there are multiple levels of security, which a lot of these manufacturers have put in. And that DLC website, that link that I put in there, gives all the information, gives all the disclosures, gives everything. Like I said, the standardization of that can be a positive and can be a negative. But I guess we'll just see what type of security protocol, whether it be blockchain, actually wins out.
Yeah, definitely. Lots of new research to do for sure. I'm curious too, one of my questions was about utility rebates, and you addressed that as well. And I know that there's different rebates depending on which utility kind of umbrella you fall under. But beyond the rebates, because part of the reason they're doing that is to transform the market. And just like what happened with fluorescents and then from fluorescents to LEDs, what do you see just based on the work that you've been doing? How quickly do you think the market will start transforming towards these wireless systems and LLLCs versus the traditional wired?
I'd like to see it go a lot faster, but like anything, the adoption of technology is, when it first comes out, it's more expensive. And then you have specifiers that don't want to change their same specifications that they've been putting out for 30 years. I have a specification that I just looked at the other day that we're dealing with, that we won the project, and it's still got fluorescent ballasts on there. And it was for the majority of the lighting. It's like a specification that they've just reproduced.
Gotcha.
They haven't written anything new, and that's one of the main things is, with a lot of work in the market and everything like that, like we're seeing right now, it's very busy. So to write a brand new spec takes a long time. A lot of these systems, as I get into the exterior lighting of systems like arc containment systems, DMX systems, and stuff like that, there's no specification. Sequoia writes it, we write it. And that's where we add, value to our clients, is we can do that kind of stuff. Where it gets into LLC is, because this is something that is not commonplace, is most likely they will have to write a updated sequence of operations. They will have to update all their spec to accommodate wireless. And so it takes some extra work, and it has to be the right project. If it's not the right project, they can specify LLC and it'll probably get changed. That's one of my jobs is, if a system is specified as ABC and it costs a lot of money, and we can show, look, it doesn't need to be ABC. You only need B and C. You don't need the A to meet code and to meet what your client wants. That's one of the things. It has to be a positive.
Right.
We can try to subsidize new technology all we want, but like we've seen with the electric car, until it's something that we actually want to see and use and looks good and gives me a reason to actually use that technology. If you can give somebody an opportunity to change their personal light level control on their phone, that would be a positive for getting luminary light level control into your facility, where they don't have to get up and hit the dimmer on the wall and stuff like that, that they can actually, maybe the system remembers what their light level preference is when they walk into their room, stuff like that. If it's, they can have their different settings. These are all things that are pretty commonplace actually in the residential market. You get different technologies, different manufacturers like Lutron, Philips, and stuff like that. They all feed the residential market. I have a Hue system in my house where I can set in each individual light fixture to exactly where I'm sitting. I can use an app and do that. But to get that on large scale in a big facility is, kind of dangerous. You can have Joe next door to Sue, and now he's messing with her lights and stuff like that. So there's definitely pluses and minuses to all these systems and to what they can do. But the main goal is to really save energy, and that's why I got into what I'm doing, is to save energy. And we talked a little bit before about energy price per kilowatt, what we're seeing here, and I think that's really a determining factor. Even though PSE puts in these $75 rebate per fixture, there's not a lot of facilities that are going towards this because they just don't need it. Energy is so cheap here. Whereas in California, LLC is very prominent. A lot of other states that have back east that have higher hydro prices, electricity prices, LLC is good when you get those rebates. And I really think that's going to be the thing. If our per kilowatt price went up to 25 cents per kilowatt, we would see a lot more LLC.
Yeah, definitely. I think there's a lot of incentives to think about and education along the way. And I don't know, I can almost see the way that it's shifting and how people could so easily change their preferences, that it's almost like we're taking that thermal comfort problem that we deal with in HVAC and then coming up with that same sort of visual comfort problem where you're trying to give people control, but not so much control that they're annoying other people, right? Like, there's a lot going on there.
Or they get confused themselves.
Yeah, exactly. Yeah. So I think we probably have time for one maybe multi-tier question here. I'm thinking for the audience that will see this eventually, there's a couple of different classes where this could be used, and primarily those would be mostly construction management students who might go the GC route or they might go to the specialty sub route, and also architects and potentially interior designers as well. So we have the construction side and then the design side. So with what you've learned about this technology and where it's going, kind of what you're seeing in the market now, and knowing that they'll probably graduate in a year or two from now, what would be your big takeaways or things that you really hope they understand on the architecture or design side, and then also the GC specialty sub side?
On the architectural side, design side, um, there's a couple trains of thought. The first is design. Does it look good? For most manufacturers, this LLC will fit into troffers. It'll fit into linear fixtures and stuff like that. For any kind of pendants and design stuff, you're not going to get the LLC designation. Those are the exempt, and I doubt it if you'll get any kind of rebate from that. Most of these manufacturers will have a secondary pack that they can put on, but I mean, if you got a decorative pendant, multiple pendants and stuff like that, a lot of the decorative stuff you're not going to be able to luminary light level control. If you can, then it's going to be an additional cost. Other than that, a lot of the pendants and decorative kind of stuff is ELV, and that's why I touched on ELV and magnetic and stuff like that. Is one of the things we see as architects and designers pick fixtures, they're not considering what's ELV, what's 0 to 10, what's magnetic. And it causes a lot of issues as it gets out to the ECs, and a bunch of stuff gets thrown together and doesn't work. That's one of my job, is to make sure that all these different technologies actually work together. And right now, here in the US, 0 to 10 pulse width modulation, that analog to digital, is really the only way that we can have this luminary light level control. Now, you throw in those decorative fixtures, which are ELV or magnetic or something like that, it causes a lot more expense. We all love decorative fixtures and stuff like that, but unfortunately, the market's not there at that point yet. Same with PoE. It's just not there with all the decorative fixtures there. So, as it comes to the GC side, it's where less time to install, less people to install. But also you have a lot of different rates, people's labor rates and stuff like that, as you get into who's installing these systems, and if it's low voltage, does it need to be an 01? There's a lot of stuff to consider coming down the pipe with these systems that are changing the way people need to look at them and account for them financially. GCs should definitely be looking at cost-saving endeavors, and wireless is definitely a big one. Switch on the wall, you can just stick it up there. It's got a little sticky pad on it that you just stick it up. You don't need to put in the conduit down. I don't need to put in the back box, the single gang box. I don't need to put in it's all there. It's sticky and put up there. But then, for the majority of time, our warranty as an EC is a year. As a GC, I can't speak for a GC. I don't know what their warranty for projects are, but as it comes to electrical, after the battery runs out in that switch, the facilities are going to have to take over for that. So I think as a GC moving forward, you have to make sure that all the training is put in place and people know what they're getting into with this technology. The more devices, the more problems.
Yeah.
So if you put a device in each individual fixture, even though the manufacturers say it's a big thing, the more devices, the more issues.
Yeah, that makes a lot of sense. I wonder too, for commissioning, just in general, big picture, is it pretty similar commissioning wise for just a typical system versus the LLLC, or just totally different flavors?
It's different once again. I mean, with the typical wired systems, you're going to a head end, everything's networked, and you sit down on your computer and you label each device and say where it is, kitchen or amenities level, all this kind of stuff. With these LLC systems, they're typically wireless, and the commissioning generally happens by Bluetooth. So the system might be Zigbee, might be 2.4, but you're using a totally different protocol, Bluetooth, to actually commission each light fixture. All manufacturers are different, the topologies of their apps, but the majority of them use apps to commission their LLCs. So it takes time. I mean, just like anything that's single addressable, doesn't matter if it's Dahlia, it doesn't matter if it's DMX. Anything that's single addressable, which LLC is, takes time. Now, some of them have the ability to, if I have multiple rooms that are the same, I can copy but it really depends. And that's where I think your question of where the GCs have to look is, these systems get put in, what training can we assure our clients that everybody knows what they're doing when they're done? Training is definitely a big part, but every manufacturer is different. So a lot of them with the LLCs use wireless Bluetooth.
Yeah, and it seems like training at every level too, whether it's install, the facility manager, or even just the occupants. Like if you all of a sudden give them their app and they don't know how to set the scenes,
the biggest thing is they forget their password.
Oh boy.
So if you can't even get past your password, man,
then good luck with the light system.
Yeah.
Awesome. Lots of good stuff to think about. This has been great. And do you have any closing thoughts or ideas?
Just on that one part, I think the future of lighting will go past individual people, facilities managers and stuff like that. There's things we're working on here at Sequoia where we put each one of our devices, controls devices, into virtual, our VDC department. So we're allocating where each one of these little packs, each device, each sensor will go into our VDC, our virtual, and we'll be able to know where these devices are going ahead of time. Now, there's a next step, which I'm hoping to work towards, is digital twinning, when I'll be able to commission a system from here. Awesome. So I'll see virtually all floors of a building with all devices, and we'll be able to remotely commission or fix issues, whether that's where the market wants to go. It's an angle. So that facilities guy that forget his password, he'll be defunct.
Yeah.
There will be no more facilities guys that has to worry about a password. They'll be doing other things. As it comes to fixing lights and all those millions of devices out there. Another thing is that a lot of these manufacturers that are bringing out these LLCs, there's a lot of ghost technology that are inside them. So the firmware is not ready. It's not written, but the devices are actually in there. So it's a good potential. Like I mentioned, that 900 megahertz meshing, that's new, but the technology was already built into their sensors long before. So now they just have to update firmware and boom, now it's a mesh network. So firmware and updating and stuff like that is definitely a big thing. And if we can digital twin all this kind of stuff, then it's better for the clients, better for everybody, better for the GCs, better for the end user.
Yeah, and then that makes sense too. That opens up a whole nother line of potential services that you all could provide.
Yep.
It saves the building operator or facility manager from having to learn all that, like you said. And I think too, just the last comment that you made, that opens it up to so many different possibilities to get creative with how these things work. So I know it's pretty exciting. I knew a little bit about it before today, but now I'm super stoked.
Cool. Right. Well, thank you.
Yeah. Well, thank you so much for taking the time today and for prepping all of this. I just can't thank you enough. Really appreciate it.
You're welcome. Thanks for including us.
Yeah. Thank you. And then I'll tell Mahmood you did a good job. A great job.
Well, thank you. Thanks.
Awesome. You have a good weekend. And I'm sure I'll talk to you soon.
Thanks, Julia. I look forward to the next time.
All right. Thanks. Bye, Mike.
Bye-bye.